AP Calculus AB 2013 FRQ number 1. It says, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine t squared over 18, where t is measured in hours and 0 is less than t is less than 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, 0 is less than t is less than 8, the plant processes gravel at a constant rate of 100 tons per hour. Part A asks us to find g prime of 5 and interpret the answer in the context of the problem. First of all, to find g prime of 5, you have to find the derivative of the given function, which is g of t equals 90 plus 45 cosine t squared over 18. The derivative would cancel out 90 and then take the derivative of the inside, which would be t squared over 18 multiplied by 45. So that'd be 45 t over 9 sine t squared over 18. That cancels out into 5t sine t squared over 18. G prime of 5, you just plug in 5 into the derivative function. That gives you negative 25 sine 25 over 18. And because this is part of the calculator section, you can plug that into your calculator to find the answer. The answer that you get should be around negative 24.588. And the second part of A asks us to explain what this answer means in the context of the problem. Because the original equation g of t is in tons per hour, then the derivative equation has to be in tons per hour per hour. This also means that negative 24.588 is the rate of gravel arriving. And because it's negative, that means the rate is decreasing. So the answer would be g prime of 5 is equal to negative 24.588. Which is the rate that gravel is arriving is decreasing by 24.588 tons per hour at 5 hours. And next, Part B asks us to find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. The keyword in this problem is total amount. This signifies that we have to use an integral. Because the hours of operation is from 0 to 8, we set up the integral from 0 to 8 g of t dt, which would also be the integral from 0 to 8 of 90 plus 45 cosine t squared over 18 dt. And once again, you can plug that into your calculator and you should get around 825.551 tons. Next, Part C asks if the amount of unprocessed gravel is increasing or decreasing at 5 hours. So first of all, we need to find g of 5 because that is equal to the tons per hour at 5 hours. And if g of 5 is less than 100, which is the rate that the plant processes gravel every hour, then the amount of unprocessed gravel is decreasing. But if it is more than 100, then the amount of unprocessed gravel is increasing. So g of 5 would be equal 90 plus 45 cosine 25 over 18. And you plug that into your calculator and you'll get approximately 98.141. And because 98.141 is less than 100, the amount is decreasing because the rate that gravel is arriving at the plant is less than the 100 tons being processed per hour. And in part D, they're asking for the maximum amount of unprocessed gravel at the plant, with justifications. The equation to find the maximum amount is the original amount plus the integral from a to b of the rate equation minus the rate of amount lost dx. In this problem, it would look like a of x is equal to 500 plus the integral from 0 to x of 90 plus 45 cosine t squared over 18 minus 100 dt. And to find the relative maximum of this equation, you have to take the derivative. To find the derivative of an integral, you basically just derive and plug in 0 and x into what the equation originally was. So in this case, a prime of x would be equal to 90 plus 45 cosine x squared over 18 minus 100. Simplify that and you get 45 cosine x squared over 18 minus 10. Set that equal to 0 to find the maximum, and then solve. Eventually, you'll get x is equal to the square root of 18 arc cosine 2 over 9. That gives us approximately 4.923, which is going to be our critical point. Now that we have a critical point, we have to make sure that it is a maximum by graphing it. The graph of a prime of x gives us this really complicated squiggly thing, and so we need to find where our critical point is, and it gives us right here. So the graph of a prime of x at 4.923 looks somewhat like this. It's going from positive to negative, meaning the slope of a of x is going from positive to negative. That means the graph of a of x should look something like this, with the maximum at 4.923. But 4.923 is not our answer. 4.923 is merely the time that there is the most amount of unprocessed gravel. So we have to plug in 4.923 into a of x, which gets us around 635.376 tons, which is the maximum amount of unprocessed gravel in the workday. And that concludes 2013 AP Calculus FRQ number 1. For more practice, you can go to College Board and find all of the other AP Calculus FRQs. There's also Khan Academy, which gives you tutorial videos and also practice problems. Finally, there are AP Review textbooks such as Barron's, Princeton's Review, or Cliff Notes that can help you and guide you through topics that are difficult for you. And that's it. Thanks for watching.